Today we're going to look at scientific notation. And before we look at scientific notation, we need to look at powers of 10 because scientific notation involves powers of 10, okay? So 10 cubed, that's 10 times 10 times 10. That would be a 1 with 3 zeros since you're multiplying the 10 3 times, and that's 1,000, right? 10 squared would be 10 times 10. That's 100. 10 to the first power is just 10. Notice we're dividing by 10 every time. So 10 to the 0, as we know, is 1, right? So 10 to the negative 1 would be 1 over 10, right? Negative exponents, you take the reciprocal. 1/10 is also a decimal, right? Or we could write it as a decimal. 10 to the negative 2 would be 1 over 10 squared, which would be 100. That would be 0.01, 1/100th. And 10 to the negative 3 would be 1 over 1,000, which is 1,000th, okay? So powers of 10 look like that, ones and zeros. If it's positive exponents, the zeros are to the right. If it's negative exponents, the decimals in front, and zeros are to the left. Now, multiplying by powers of 10, you could do this in a calculator. You could say, let's say I have 4.32 times 10. Then you could do 4.32 times 100 and 4.32 times 1,000. You could do 4.32 times 1/10 times 100th times 1,000th. And what you're going to see is that multiplying by powers of 10 moves the decimal. That's all a power of 10 does when you multiply by it. It's either going to move the decimal left or right. A positive power of 10, that's these bigger numbers, right? A positive power of 10 moves the decimal to the right, okay, because that's going to make the number bigger, right? If you multiply by 1,000, it makes the number bigger, so the decimal is going to go to the right. And a negative power of 10 moves the decimal to the left. So powers of 10, which you should have at some point explored, played with, seen what happens when you deal with powers of 10, moves the decimal right or left. So like I said, scientific notation has to do with multiplying by powers of 10, either positive powers of 10 or negative powers of 10. So scientific notation is a way to write really, really, really big numbers or really, really, really small numbers. It's called scientific notation because it's used a lot in science. If we're trying to find the distance from here to Pluto, that is a big distance, and we would not want to write all those digits out. So we would use scientific notation. If we're looking at a cell under the microscope and we talk about the diameter of that cell, that would be a fraction. That would be a little bitty decimal number. We wouldn't want to write it all. We would write it in scientific notation to make it easy to read. Now, the rule of scientific notation is that there can only be exactly one digit in front of the decimal multiplied by a power of 10. Okay? So there's exactly one digit in front of the decimal, and it's multiplied by a power of 10. So you see here 9.62. One digit in front of the decimal, and it's multiplied, and we will use the little times symbol. We don't use that much anymore, but in scientific notation we do. So times a power of 10. One digit in front of the decimal, there's the rest of the number, times, using the little times symbol, the little x, a power of 10. So here's what you do. You could do this with a calculator. If you didn't know what was going on here, you could say, well, 9.62, 10 to the 5th is going to be 10 times 10 times 10 times 10 times 10. That's a 1 with 5 zeros. You could probably put that one in your calculator and get an answer. Sometimes these are too big to put in the calculator, but you could do it. But what we're going to look at is the shortcut of moving the decimal. So we write the 9.62. We're multiplying by a positive 5. So a positive exponent is going to mean a big number. A positive exponent is a big number. If we're multiplying this by a 1 with 5 zeros, which is 100,000, this is going to get bigger, right? And you're going to move the decimal that many times. So this is going to go to the right 5 places. So we're going to move this decimal, and we're going to use Miss Gibbs' very technical math term, swoopies. We're going to do 5 swoopies. 1, 2, 3, 4, 5. It's getting bigger because we're multiplying by a big power of 10. Any empty swoopies, we're going to put zeros in. And then we're going to rewrite this number as 962,000. So that's the number in standard form. That's normal form. This is scientific notation, okay? Next one, 2.85 times 10 to the negative 6. A negative exponent indicates that we're multiplying by, this is going to be what, 1 millionth, I believe. 1 over 10 to the 6 is going to be 1 millionth. That's a little bitty number. A negative exponent is a small number, and that's going to tell you to move your decimal left, because this is actually a small number. If you see a negative exponent, that means this is a little bitty number. So we're going to copy the number, 2.85, and we're going to move the decimal 6 places. You look at that, that tells you how many, to the left. So we're going to make swoopies again, and we're going to go 1, 2, 3, 4, 5, 6. Now my decimal is now moved right there. So I'm going to fill in my empty swoopies with zeros, okay? And then I'm going to rewrite my number. I'm going to put 0 point. That helps my decimal point stand out. I've got 5 zeros and then 285. So that's a little bitty number. That's something you're looking at under the microscope, okay? Now you've got the rule. You write these two numbers in scientific notation into standard form, then turn the video back on and check your work. Okay, so check your answers, see if you have any questions, fix it if you need to, go to the next slide. So now we have numbers in standard form, that's normal numbers, and they want us to write it in scientific notation. Keep in mind your goal is 1 digit in front of the decimal. Only 1. So we look at 931,500,000, and where is the decimal right now? Well, from any whole number, it's at the end, right? We only want 1 digit in front of the decimal, so the only one we can have is this 9. So we need to move the decimal from the back to right behind the 9. So we're going to swoopy over there, and we're going to count while we swoopy. We're going to swoopy 1, 2, 3, 4, 5, 6, 7, 8, right? So that's kind of little. I think I did that right. So we end up with 9.315. Part of the purpose of scientific notation is to leave off all these zeros, okay? We don't need those zeros. So whatever zeros are at the end, leave them off. So 9.315 times, use the times symbol. Since we moved the decimal, it was a power of 10. We moved it 3, 6, 7, 8 times, and was this a big number or was this a small number? This is a great big number, right? 931 million is a big number. So it's going to be a positive 8. So a large number, and by large I mean value, not just the number of digits it has. So large number is positive exponent. Okay, we would have to multiply this number times a big power of 8 to get it back to what it started. Now, look at the next one. 0.00443. This is what? Tenths, hundredths, thousandths, 10,000ths, 100,000ths. So this is 443 100,000ths. This is a microscope number, okay? Now, the decimal is right here. We need 1 digit that's not a 0 in front of the decimal. So we need to move the decimal here. So we're going to swoopy over 1, 2, 3, 4. I messed that up, didn't I? Let's try that again. We're going to move it over 1, 2, 3 places. So we're going to write 4.43. Part of the purpose of this is to not have to write all these zeros. Times, you're going to use the multiplication symbol. Since we moved the decimal, it was a power of 10. We moved it 3 places, and we need to look, was this a microscopic number or a huge number? Well, this was a microscopic number. So a small number, a microscopic number, something under the microscope, is going to be a negative exponent. So we get 10 to the negative 3 because the decimal was out in front. Okay? So here are 2 more that are in standard form. You write them in scientific notation, turn the video back on and check it. Did you get them right? Remember not to write any extra zeros. If it's a large value, like you would like that kind of money, you want a positive exponent. If it's a microscopic value, it's a negative exponent. The last thing we need to talk about, because this is going to come up the next lesson when we start doing operations with scientific notation, is how to fix numbers that aren't in scientific notation. So like right here, we've got times a power of 10, but this is not right. It's got 2 digits in front of the decimal, and we need 1. Now, there's a couple of things you could do here. You could write that out in standard form. You could say 29.5, you could move it 4 places, 1, 2, 3, 4. You'd get that. You'd get what, 295,000. And then you could go, okay, now I need standard note or scientific notation, so I'm going to go 1, 2, 3, 4, 5, and I'm going to get 2.95 times 10 to the 5th. So you could change it to standard form, then change it back to scientific notation. That will work. But you see, you might have some bigger exponents. Not a huge deal, but it may be more than what you want to do. So what you can look like at this one, was this number too big or too small? Was the 29 too big or too small? It was too big, right? Because we needed a 2 there, not the 29. So if it was too big, you add to the power. You add to the exponent, okay? We needed to move this 1 more place, right? It needed to be moved 1 more place. It was too big. We could add 1, so we should get 2.95 times 10 to the 5th, okay? Now, look at this next one. We could write it out in standard form, move it back in scientific notation. But if you notice, we really only have to move it 1 place, right? We need that decimal right there. What we really need is 9.944. Now, what's my new exponent going to be? Well, this was too small, right? This number was too small. It was 0.9 instead of 9.9. So if it's too small, you subtract from the exponent. So I moved it 1 place, so I'm going to subtract 1. So I'm going to get times 10 to the 9 minus 1 is 8. Again, you can change it to standard form and change it back, or you can just look and say if it's too big, I'm going to add however many places I have to move. If it's too small, I'm going to subtract. You try these 2 down here, then turn the video back on and check it. All right, this one was too big to begin with. I had to move my decimal 1 place, so I added 1. Negative 4 plus 1 is negative 3. This one was too small. I had to move my decimal 1 place, so I subtracted 1. Negative 9 minus 1 is negative 10. All right, if you have any questions, ask them. Now you're ready to do your practice.